Hey everyone, welcome to our talk Everything is a C2 if you are brave enough. Second chapter by Ángel Ramírez Mendoza and Mauro Eldritch from DC 5411. Before we start, as we always do, we will make a short introduction on ourselves, the speakers, and on the main topic of this talk. I am Mauro Eldritch. I'm an Argentine hacker and founder of the VCA and DC 5411, Argentina and Uruguay. This is the main DEF CON group for both of these countries. I spoke at different conferences around the world, including DEF CON and Easy Council Hacker Halted. And this is my second time here at the Texas Cyber Summit, so I am really happy to be here today, and we're going to give our best. Now, my co-speaker, Professor Ángel Ramírez Mendoza, is going to introduce himself. So please, Luis, go ahead.
Okay, thank you, Mauro. Hi, my name is Ángel Ramírez Mendoza. I am from Colombia. I am working at the Security Hardware Engineering and VCA, member DEF CON Group 5411, and a speaker in different conferences, including DEF CON, Dragon Heart, PostCon, Texas Cyber Summer, Great Heart, beside Newcastle, JazzCon, beside Isla Bam, Honeycon, Coesi, and ROSCON.
Okay, thanks, Luis. So, this talk is about building the most crazy and unexpected and also interesting C2 server that you have ever seen. We are going to use the most innocent platforms, the most unsuspecting platforms and applications that you have lying around your desk, and we'll try to weaponize them in order to build a C2 server. What kind of applications are we going to use now, or have we used it in the past? Messaging apps, online profiles from online platforms, music streaming services, video games and gaming platforms, and there's even a little bit more today. So we will start by the basics. We will explain from scratch how to build a common and basic C2 server, and then we will base this very same C2 server on different platforms and applications to relay its commands. So for this, we have created a toy ransomware, which will try to call home, exfiltrate some information, and coordinate an attack using, as I said before, the most unexpected and innocent-looking ways. Before we start, there's something that we would like to clarify here. This is a beginner-friendly talk, so all the samples shared here are unable to deal any kind of damage to your targets. You won't have any problem with this. They are only built for educational purposes only. These artifacts won't deal any damage to your infrastructure. They will actually only leave a fake ransom note on your desktop, nothing else. So there's nothing dangerous going on here. This is not like playing with a real malware sample. And obviously, since this is a toy ransomware, some real features that you can see on real samples will be obviously missing. And obviously, all this research is legal, and there's absolutely nothing directly or indirectly illegal involved. So, having said this, let's start with the basics. A first glance at a really basic C2 server. So, what is a C2? C2 stands for Command and Control Server. It's obviously controlled by a bad actor, a bad part here. It will coordinate and distribute orders or commands to its infected systems. What can a C2 server do? Well, data exfiltration, lateral movement, calling home, and a little bit more. It will obviously try to blend its traffic among normal applications or as normal activity in order to disguise itself. It won't say, hey, look at me, I'm a C2 server, and I want to reach back my infected systems. It will try to be as silent as possible. And these C2 servers have really different connection models, like peer-to-peer, centralized, or even random. We won't dig further into this last point actually, as we will try to keep things simple. So can you give me an example? Yeah, we'll set up a really basic C2 server, as I said before, with its corresponding client, and it should be able to do the following. To register a new victim, once infected, to share an encryption key, which will actually be a public SSH key. Funny thing is that there are some ways to encrypt a file using SSH keys, but we won't dig further into this. Actually, it's just as a comment. It will help to leak information from the target, specifically the hostname and the IP address, and encrypt the target's file system. But worry not. As I said before, we will only leave a fake ransom node on the desktop. This talk is given for free. We are not going to ask you for anything strange. Don't worry. And not yet, but we are going to do it in a minute. We'll try to disguise the traffic using a well-known application or service. This is the main topic of this talk. So it's crime time, but we don't like to do things just so simple. We have to give a background story about why are we doing this ransomware thing. So to make things funnier, we'll create a new ransomware gang, the Capybara gang. Capybara are these really nice and fluffy creatures that you can see on the right. They are native to both Argentina and Uruguay and also Brazil. So we are going to beat this Capybara gang, and we'll be dedicated to stealing Capybara coins from our victims. Our ransomware nodes will ask exclusively for this kind of coins, which, something more funnier, actually exist. In Uruguay, we have these Capybara coins, which are actually a small coin of 2 pesos. So that's why we have radicalized ourselves as a ransomware cartel. Okay, let's explain the basics here. For our server, we'll use Ruby and Sinatra, which will allow us to build a really simple and friendly API. I know that interpreted languages are not commonly used for this kind of software in the real world, but it's way more understandable for this talk, especially if you're a beginner. You don't want to start wrestling with C code, so this is for the best. We'll require common libraries, like I said before, Sinatra for this API, and the other ones will only allow us to make specific HTTP calls, and Colorize will help us to distinguish the output by color. So we'll define some really basic endpoints, and let me add here that all this code is open source and available on our repository, which will be shared in a minute when this talk is over. So you will have access to this code base. So back on tracks, we'll define some very basic endpoints addressing all these previously detailed points. For example, reserving the ID for each victim, generating a key pair, leaking the basic information from the compromised host, and notifying when we are going to finally start an encryption operation. Remember that this is a fake operation. This last endpoint, order, allows us to connect back to a compromised host, using obviously the leaked information as a sort of connection string, and we'll query the telemetry endpoint and issue a custom command for this. And this custom command is obviously password protected. We don't want anyone snooping on our malicious activities. The client is really quite simple. It will query the server's endpoint sequentially. All of the previous things that I mentioned that the server should do, well, they will be done when the client queries the specific endpoints one by one. This is like a routine. Once this routine is finished, we will have our ransom node placed on the desktop. So far, so good. We have shown the actual demonstration of this basic C2 server in the other chapter, but due to time constraints, we won't be able to show it here. But I will make sure that you get the idea. On the upper left corner, this is the server, which has different outputs from the actions that were requested by the client. As you can see, it says a new victim has been compromised with ID number ending in 1. It will generate a new key pair. It will leak the following information, as it says here, the hostname and the connection string, which is the IP address and port, and it will send the encrypt order. On the right, upper right, you can see the client, which says, okay, I'm getting the ID, I'm getting the key, and leaking the information, and I will raise a small Sinatra API in order for the server to connect back and send the commands. And on the lower part, you can see that on my desktop, which actually Escritorio translates from Spanish as desktop, we don't have anything strange, only a folder. Then when we are simulating this command, we are sending the order encrypt with the password which is protecting this endpoint. The encryption operation will be simulated, and we will have a ransom note placed here, which says your files are encrypted. Send us 2 capybara coins to decrypt. So now we're moving to the weird part. This is a normal C2 server, a really basic one. And what we want to get now is the most wacky clients. Professor Luis is going to talk about the past clients that we have built for the first chapter of this talk. Please, Luis, go ahead.
Okay, thank you, Mauro. In the previous chart of this talk, we have shown a different client. Let's start a look. This is the YouTube client. It gets command from YouTube planning. We read the video title. This is the Spotify client, and it gets the command from Spotify planning. Each song is the command as we can see here. This is the Wikipedia or Media Wiki client. It will be reading a specific user page. This is the Steam one. It's reading command from a Steam user page. The real name field contains code for to pastebin contain the encryption key and C2 address. This is the Warcraft client. It works on provided World of Warcraft server by parsing a specific character chat. The character can see command automatically to victim.
So what's next? So far we've been able to register a new victim, to share an encryption key, to leak information, to encrypt the target's file system, but we are not able to disguise this traffic, so we'll try to do so using a well-known application or service. Let's roll. The Discord client. This is a really basic example here, and Discord has been used in the real world to build C2 servers for worldwide campaigns, malware campaigns. So we thought that this will be a good example to give, actually, even though that it might look rather simple. But this will be really simplistic and also friendly to beginners. Creating a Discord bot is something trivial. There are a lot of libraries, gems, and whatever you want to look for in order to build your own Discord bot. And also the community is really friendly with beginners and with developers, so you will be welcome there if you want to build something like this. And actually you will find a lot of material around. It won't take almost no time on coding and almost no time on setting up. It's privileged, and since you will be the only user, you won't have to send this to users to authorize or to approve the permissions. You just have to give the permissions to your own channels. So this will be a walk in the park. All of our clients, the ones that you will see on this edition and on the previous edition, are actually based on the very same set of commands. So there's nothing was changed from this edition to the previous one. You will have sequence start, set key in order to download the encryption key, leak info, which will leak the information, only the hostname and the upper IP address that the host can share, to start the encryption cycle and to end the sequence. So let's go directly to the demo here. Okay. The upper right corner will actually run a Capybara client. We'll use Discord as our command relays here, and this one will monitor our desktop in order to look for the ransom nodes being placed there. We'll start the Capybara client. This is a normal Ruby gem for building Discord bots. Now we'll show that our desktop is empty. No txt files there. Remember, escritorio is desktop in Spanish. We'll send the sequence start. The bot won't say anything to us, but the client will know that it has received the sequence start. We'll send the key, obtained key. Link information in case we want to connect back. That's when our bot answers us. Remember that all of this will be available on GitHub. We'll start the encryption cycle and send the sequence end. Then you wake up one morning and on your desktop you have this. Your files are encrypted. And it goes like, okay, your files are encrypted. Send us 2 Capybara coins to decrypt. Capybara coins are the official Uruguayan currency. 2 pesos coins feature a nice and friendly capybara, and we want all of them now. So this guy seems serious and they don't want to negotiate. So let's go back. Okay, so this is basically how the Discord client works. Really simple, really beginner friendly, so this is maybe the best start point if you want to test one of these examples here. Now the Slack client. This is just a little bit more difficult than the previous one, but only for bureaucratic reasons, not for programming or computer skills reasons. Using the Slack API again to create a bot will be enough. And now it's a good time to mention that Slack was actually used too as Discord to coordinate different malware operations, worldwide operations, or as used like a C2 basically. So this was worth trying once again because this may not be as wacky as it seems. So again, the problem here will be bureaucracy, not actually computer skills. The model that Slack uses is really complicated. At least for me, it was really complicated compared to the other models that we have out there, like the Discord one or the Telegram bot father or so on. And the company is dropping certain authentication methods which are becoming legacy now. So this client will probably change or be refactored in the future. I don't want to say that it's the least favorite, but I don't want to imply that. So commands are exactly the same as on all the other clients, and we only added the bot to answer on every message sent, because the gem that we are using here and the libraries that we are using are really verbose, and it's really easy to get lost while trying to debug it. And every other behavior stays the same. Let's roll over to the demo. So again, the upper one is the bot. As I say, it's really verbose, so it's easy to get lost. Now our desktop is empty and we start sending message. You may have noted by now that all these C2 servers, these toy C2 servers, are manually activated. You have to send the commands for each one of them. And you might say, hey, this is not a C2 server, and you are right. So actually we have some examples that act on behalf of the user when manually activated, and others that do that automatically. This is done on purpose because we want the beginners to be able to track every action at once. So here we have the ransom note, which contains exactly the same text. So as I was saying, we want the beginners to be able to control what every action does and modify it if they want. So some clients will be automatic, some others will actually be more, let's say, more manual. So this is basically how the Slack client looks. Remember that this is a manual one. Now is when things start becoming a little bit more crazy. If you don't know Assault Cube is an open source 3D person shooter, like a Counter-Strike based game. And we wanted to use it just like we did with World of Warcraft in the previous edition. And we wanted to do it the same way, by relaying the chat conversations to a Sinatra listener, which will then publish them over the network, and then will be fetched by a client. Remember that the victim doesn't need to be playing Assault Cube, doesn't even need to know what Assault Cube is, and you don't have to send a client or make the victim play Assault Cube in any way. You only have to play yourself. So this introduced a new artifact, the wrapper. We had to build a wrapper around the Assault Cube to redirect all its output to a file to then be fetched up by the server, interpreted, parsed, and extracted by user. In this case will be Mauro Eldritch. Then it will have to parse again all the chats from that user, looking for those that make sense to be orders, right? And then the client will come here and reach the server and execute those published commands when they meet the natural order. Remember, sequence start, blah, 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 sequence end. So now we can jump directly to the demo. Okay. As I said before, this one is a little bit different. The wrapper is already running on the upper right corner. We start sending commands like sequence start on Assault Cube on the lower left, set key, leak information. Remember that this one is not a manual one. This one is automatic. Grip start. This means that you don't have to interact manually for each infected system. Then we send the sequence end. We run a little bit, just move a little bit. Now we execute the server here. We keep the wrapper alive. The server will start a new interface and parse the logs instantly. There's no delay here. Port 4567. Now we run the client and it will automatically fetch that information and execute it. Now we can look if our desktop has any suspicious file. Well, it seems. So, better to have a cyber insurance soon, right? Oh, not again. Okay. Now the DNS client. We don't know if anyone using actually DNS registry for this kind of thing, but we found it to be funny, and also beginners and we won't have a problem actually trying this. Maybe the problem is where to publish DNS registries, but well, that's a little bit out of scope here. So using TXT records we can get some promising results actually. The only downside that you have here is having to wait for the DNS entries to replicate, and also having a place where to, as I said before, have access to modify these DNS records. That can be a little bit trickier if you are just beginning with this. This is a really simple demo. Let me just start it. We have the client here and our desktop. We have our domain from our RV sites, which already have all those registries. As you can see, this worked like a charm in just a second. This is not locally hosted. Let's look for its txt registries, and you can see that 5 of those 6 belong to Capybara, actually. And this can be happening to us again. And yet again, this is happening to us. Okay, this was a really short demo. So, okay. Once again, this is how it looks. On the left, the registry obtained via the dig tool. And on the right, the client being executed and the ransom note. So far so good. This was really fun. It was really nice to be here today, but it's time to go. Our conclusions are pretty simple here. Since these examples are not a real danger, they can, and actually some of them, like the Discord and Slack examples, were used in the past and in the wrong hands, and were used maliciously, with malicious intent. Never assume, because what may seem to normal traffic to some encyclopedia or streaming service, or what could be the developers playing Assault Cube, can be actually be hiding something else. Also, Assault Cube runs on almost any hardware and operating systems, in case you are interested. And if you are brave enough, anything can be a situ. So, this is it, folks. We are Mauro Eldritch and Larm182Luis on Twitter if you want to follow us. All this code will be available on GitHub too, in case you want to give it a look, a try. And it will have the same repository, the previous edition servers and the local ones. And if you have any questions, we are more than happy to answer them here